All right, so what we have here is the chain and the product rule combined. We're going to break these up into two parts, with this first part being U and this second part being V. I know I have to do this because these two functions are being multiplied together. So if I go ahead and start with U is just 1/2 x squared. The derivative of U is 1/2 times 2 times x to the first, or just x. Now, for the next one, I have V. I'm going to rewrite V as 16 minus x squared to the 1/2 power. For V prime, I need the chain rule. So the first thing I want to do is take the derivative of the outside. I do that by bringing the 1/2 out front. Then it's going to be 16 minus x squared. I subtract 1 in the form of 2 over 2, so that's going to be to the negative 1/2 power. Now, I have to multiply this times the derivative of the inside part of my function. The derivative of the inside part of that function is just minus 2x. Again, the 16 goes to 0, the negative is there, the 2 comes in front. So to simplify V prime, it's just going to be the combination of 1/2 times that negative 2, and I am just left with a negative x times 16 minus x squared to the negative 1/2. Now, once I have all of this done, I can go through and use a product rule. The product rule tells me that I have to have U times V prime plus U prime times V. So U is just 1/2 x squared. V prime is negative x times 16 minus x squared raised to the negative 1/2. Now for the next portion of this, I have U prime, which is just x, times V, which is my 16 minus x squared to the 1/2 power. We can simplify this a little bit, and I can simplify that by just writing this as my first derivative is equal to combine those two x's to be negative x to the third all over 2 times 16 minus x squared plus x times 16 minus x squared to the 1/2 power. Oops, excuse me. All right, so for this question, what we have is a combination of the chain rule and the quotient rule. Meaning the biggest portion of this is the inside piece. All of this we're going to let be U. So all of this is going to be U. Now, we're going to use the chain rule first. So we're going to take the derivative of the outside, which is going to be 2. Everything on the inside, that U stays the same for the chain rule, all divided by 2x plus 3. That is now to the first power because I subtracted 1 from the outside. Now I need to multiply all of this times the derivative of the inside. Now, to find U prime, I need the quotient rule here. So, what is the quotient rule? Well, I have the derivative of the numerator The numerator of the function is 3x squared minus 2. The derivative of that numerator is just going to be 6x. Now the denominator of my function is 2x plus 3. The derivative of the denominator is just 2. So when you're going through and using the quotient function, it is the derivative of the numerator times the denominator, which leaves me with 6x times 2x plus 3. Then I have to make sure I subtract, and I subtract out the numerator times the derivative of the denominator. So I'm subtracting out 2 times 3x squared minus 2, and that's all over the denominator 2x plus 3 quantity squared. So let's simplify all of this a little bit. And I'm left with g of x is equal to 2 times 3x squared minus 2 all over 2x plus 3. And all of that is going to be multiplied by, I'm going to take and distribute this piece in the numerator. And when I distribute that in the numerator, I am left with 12x squared plus 18x minus 6x squared plus 4 all over the denominator squared, which is again 2x plus 3 quantity squared. Now notice the denominator over here also has another 2x plus 3. So I forgot my prime notation there. So g of x is equal to 2 times 3x squared minus 2. Simplify up here. I'm going to combine my x squareds, and I'm left with 6x squared plus 18x plus 4 all over 2x plus 3 to the third power, and again because I combined those. Question is a case of using first the chain rule, then the quotient rule. All right, for the next question, it's very similar to the last one. We're just going to do it in an opposite order. I have y is equal to the square root of x to the 4th plus 4. Now, for this one, we start off and we need first the quotient rule and then the chain rule. So u is the numerator, which is just x. The derivative of the numerator is just 1. For v is the denominator, and I'm going to rewrite the denominator as x to the 4th plus 4 raised to the 1/2 power. And this is an example of when I need the chain rule. The derivative of v, I take the derivative of the outside first. And remember, when you're taking the derivative of the outside, the inside stays exactly the same. And subtract 1. So that is negative 1/2. Now I go ahead and I need to take the derivative of the inside. That's the chain rule. So I'm multiplying it times the derivative of the inside, the derivative of x to the 4th with 4x to the 3rd power. All right, so to use the quotient rule, now I have the derivative of y prime is equal to the derivative of the numerator times the denominator. So that leaves me with 1 times x to the 4th plus 4 to the 1/2 power. Now I have to subtract. I subtract the numerator times the derivative of the denominator, which leaves me with x. And I'm going to go ahead and combine where I have the 1/2 and multiply it times 4x to the 3rd, and that's just going to leave me with times 2x to the 3rd times x to the 4th plus 4 to the minus 1/2 power. Again, this is all over the derivative of the denominator, so it's the square root of x to the 4th plus 4 quantity squared. Now we need to simplify this a little bit. And for this, we are left with y prime is equal to x to the 4th plus 4 to the 1/2 power minus 2x to the 4th all over x to the 4th plus 4 to the 1/2 power, and that is all over x to the 4th plus 4. I don't want to leave this as a complex fraction, so the only part of this that makes it a complex fraction is this second fraction right here. So if I look at whatever this is in the denominator, what I want to do is multiply this fraction by 1, multiply it by x to the 4th plus 4 to the 1/2 in both the numerator and the denominator. When I go through and do that, I'm multiplying it by both terms in the numerator. When I do that, what I'm left with is I have y prime is equal to x to the 4th plus 4. Now, what's happening here is both of these are on the inside are the same. So all I have to do is add the exponents, 1/2 plus 1/2, so that's exponent, and that's going to be the exponent to the first. Now I subtract 2x to the 4th from that. And that's because when I go ahead and multiply this fraction times this, the denominators cancel out. That's by design. Now in the denominator, again, I'm adding the 1 and the 1/2, so that leaves me with x to the 4th plus 4 to the 3/2 power. Simplify the numerator, and I have, remember that's 1x to the 4th, so I'm going to be left with negative x to the 4th plus 4 all over x to the 4th plus 4 to the 3/2 power.